Welcome to the Physical Science Connection. Today's lesson is on measuring motion. Alright, so when you want to measure motion, one of the things you want to look at is the slope of a line. The slope of the line indicates how steep that line may be. It's the change in y over the change in x, or, in another way of saying it, the ratio of the rise to the run. There are two ways typically that you can solve for slope. You can either have the points that you need, both points, at least 2 points on a line, and you can use those points to plug into the slope formula and then solve. Or you can have 1 point, finish off the graph, creating another point, and then also solving for slope in that manner. We're going to try both methods today. So we have our first one here. It says to determine the slope of a line that passes through 2, 5, and 7, 10 using the formula y2 minus y1 over x2 minus x1. So we're just going to go ahead and plug our values in. y2 is the 10. It's the second y value. Minus y1, which is the 5, which is the first y value. And then we have x2, which is the second x, minus x1, which is the first x. And what we have is 5 over 5, which equals a slope of 1. So that's just one way that we can solve for the slope. Another way to solve for the slope is having 1 point and then finding the slope of that line based on just that much information. So what we'll do, we'll go ahead and find our point 54. All right. There we go. And then we're just going to draw a line from that point and the point of origin. And then in order to find the rise and the run, we want to look at this section right here. This is our rise, and if you see we've moved 4 places from the x-axis, and then our run is 5 places. So our slope, which is indicated by the letter M, is 4 over 5. Because our line increases from left to right, it's going uphill, we have a positive slope. Now we've seen how rise over run and measuring slope works with just math, but again we can apply this to science concepts such as speed or velocity and acceleration. So what we have here is a table, and on the table we'll look at do a comparative analysis of how slope is used in every situation. When we're looking at y over x, that's the rise and the run on a coordinate plane for math, and it's really the rise and run for all 3 areas. But y on a speed graph would be distance, while x would be the time, and in an acceleration graph y would be speed and x would remain time. Again, we have a upward or an uphill line indicating a positive slope. In science, when we look at speed, then it means that your object is moving forward. On an acceleration graph, it means your object is speeding up, because then if speed is your y-axis, your dependent variable, as the line is moving up, the speed of the object is increasing or accelerating. Then you have a line from left to right. It's going downhill or decreasing. That is a line with a negative slope. On a speed graph or velocity graph, the object would be reversing or moving backward. And then on an acceleration graph, the object would be slowing down. A horizontal line indicates a zero slope in math. Now, the slope is still zero, but when we interpret it in science, it means that the object is not moving. So the object is staying at a particular distance for a certain period of time. On an acceleration graph, it means that the object is maintaining a constant speed over a given amount of time. And then we have the vertical line. No matter how you look at it, whatever context it's in, that line indicates an undefined slope. So let's determine the slope of a line when a person runs 126 meters in 14 seconds. We also want to find the speed that that object or that person is traveling. So again, here we have our y-axis, and here we have our x-axis. So we're just going to go ahead and label. And you want to always remember to label so that you don't get your put your variables along the wrong axis on a graph. We have our point of origin. And since we were talking in seconds, I'm going to go ahead and put this here that indicates seconds. And then we have meters. And we're going to go ahead and put these in 20s. All right, I think we are ready. So we need to go ahead and find this point. And so at 14 seconds, this person traveled 126 meters. So right about here, I'm just going to take a line and I want to make it as straight as possible to get to this point. All right. Now, the speed that this person was traveling, to find that, you can divide 126 meters by 14 seconds. And you should find that the person traveled, their speed was 9 meters per second. Now the slope, how do we find the slope? When you're looking for the slope, you need to find 2 points. And it could be any 2 points. You just need to find 2 points on your line that intersect well on the graph. So I'm just going to write these. All right, so to find slope, you need 2 points. You want to find the rise, then the run, and then you need to determine if it's positive, negative, and since our line is moving upward, then we're going to have a positive slope. And that's your lesson on measuring motion.